to show how the performance bar feature works in GitLab. So the performance bar has to be enabled by an administrator, and it can be enabled for a specific group of users. So on gitlab.com, it's enabled for everybody who works at GitLab, essentially. That means that as I work at GitLab, I normally see this when I'm logged in, but if I hit the P, then B keys, P for performance, B for bar, I'll see the performance bar at the top of my screen. Left to right, what we have in the performance bar is, first of all, the host I'm using. So in this case, it's got a yellow chick because we're on the Canary host. It's got the time and number of SQL queries, the time and number of Gitly calls, time and number of Redis calls, plus icon that we'll get back to later, and a drop down on the right. So the host, like I said, is fairly straightforward. This is mostly useful internally, but also to know if you're on Canary or not. We have this next indicator, and we have the favicon change. This is just another way of verifying that. The Postgres queries, so all three of these, if you click on them, you'll get the details of the queries that this page has run. So for instance, we can see that the slowest query on this page took 3.31 milliseconds, and it was to get the list of to-dos for my user, to get if there are any pending to-dos for my user. And if I click on here, I can see the backtrace, and you can see that it's come from the pending to-do for method on the user object. Further down, we can see some other queries. This one looks a bit scary, but that's just because it's aliasing every single column in the project table. So it looks scarier than it is, but there's nothing really to worry about here. 53 milliseconds is pretty okay for a page, given our current situation. 50 queries, ideally we could reduce that in some way, but it's not the end of the world either. This is an issue page, so it makes no Gitly calls, which is what that's going to say. And it also hits Redis 16 times, which we'll come to a bit more later because there'll be some more interesting pages. The plus button here is kind of an advanced feature, so I'll go through that later. Here is the request selector. So everything here is showing for my initial page load. But the initial page load for an issue doesn't, for instance, load the issue comments. That happens in a separate call to this discussions.json endpoint. If I click that, I can see that, okay, this actually runs more queries. It's run on a different host. Previously, I was on Canary 03, now I'm on Canary 02. And the queries themselves take longer. So we've got 112 milliseconds spent in Postgres on this page. Have a quick look at that. I can see that most of it seems to be selecting some issues. I'm guessing that's because those are issues that are mentioned in the markdown for the tooltips. And that is in fact it. So Banzai reference parser is what that means. It means that if you mention an issue URL or reference in another issue, when you hover over it, you get the title, and you also get an indicator of whether it's closed or not in the reference text. 30 milliseconds does seem quite high for that, but it's also not slow. So that's the basics for an issue page. We're going to move over quickly now to a merge request page, which is a bit more interesting. So first of all, I'll refresh the page to get the performance bar. Now, hopefully the immediate thing you notice on the merge request page is that there's this yellow warning icon. So that's saying that we've got 282 queries run when you initially load a merge request, which we think is too high. We've set a sort of soft limit of 100 for an individual request, and this is obviously way over that. So that's what that warning means. There'll also be a warning for if Gitly calls exceed the amount we want, or Redis calls do, or the timings exceed. In this case, the SQL queries are quite fast. There's just too many of them. So we can open this up and have a quick look. Right, so we've got a select count from something that's seeing if a CI pipeline has any of these shars, and there's a whole bunch of shars. We can see that this is selecting something to do with users who can approve the merge request. This is about trials, which I think is run on every page. This is run on every page as well because it's about GitLab subscriptions. Again, I can validate this by looking at the backtrace, and here I can see that, oh, actually, no, sorry, this is to check if a feature is available for this merge request. So that's not what I thought it was, but that's the whole point of the backtrace, that I can validate this. And if I keep scrolling down, you can see that there's a whole bunch of queries. Some of these may be duplicated. So like, there might just be literally repeated queries, or there might be n+1 queries. For instance, here you can see that we do what looks like a very similar query twice in a row. One is for source pipe, one is joining on source pipeline ID, and one is joining on pipeline ID for the same ID. And one has a limit 1 and one doesn't for some reason. They're both very fast, but having those two does seem like something we could combine into another query. We've got another one here for source pipeline ID, so I don't remember if the ID was the same. It doesn't look like it was, but again, we've sort of got like extra queries there. Merge requests, as they also involve the Git repository, are more likely to run gitly calls, so we've got some here. These are all, again, pretty fast and pretty acceptable. So we find commits. Sorry, there was a bit of background noise there. We find commits, we need to list some, and we find some more and get some commit messages. So that's all pretty straightforward again. We can also see the backtrace for these commits. So in this case, what's interesting is that this find commit has come from the reference parser. And again, that's when something is mentioned somewhere in the merge request description or something like that. So I mentioned that this request has a warning. That's also indicated by the exclamation mark in the drop-down box. And there's another warning sign here, which says that there are 3 requests on this page with warnings. So if we look at this, we can see the other 2 exclamation marks of the widget JSON. Widget in this case means the JSON that fills in this, what we call the merge request widget, with all the merge request information about pipelines and so on. And if I click on this, again, we can see that the slowest query is still fast, but there are 199 queries run by the widget. That's particularly problematic in this case because you can see that there are 2 requests for the widget. There are actually more. The merge request page polls the merge request widget in case the status has changed. The performance bar will only show the first 2 requests for a particular URL, because otherwise that could quickly become overwhelming if you see the same request name a bunch of times. Okay, next up, we're going to go back to the issue page and look at this plus button. So this is for adding a request manually. So this is showing me the requests that were made by loading this page. But sometimes I might want to know what would happen for another request. So for instance, this is the JSON view of my activity calendar on my profile page. And maybe for some reason I can't, obviously in this case I could just go to my profile page, but it's a nice example. So I can enter a URL here, and that will make the request. It has to be a JSON request if it's a URL, because it's using XML HTTP request. And then it will include that in the performance bar. So we can see that it makes 6 queries, but it takes 713 milliseconds. So one of those must be pretty slow. And indeed it is. It takes a third of a second, and it's a gigantic query that is selecting events and from certain projects. It's chunking in by date possibly as well. It comes from this contributions calendar module. And then we have another query that takes about a third of a second as well, which is selecting projects from a list. And anytime you see a select distinct, that's always a sort of raised eyebrow. It's not necessarily a problem, but quite often you don't need distinct, even if you think you do. So yeah, that's something that could be improved, but it's probably not a super high priority right now. We can also see that page makes 2 Redis calls. Neither of them are particularly interesting. One place where the Redis calls might be interesting on this page is that there's this related branches endpoint for an issue. And obviously it's talking about branches, so it should touch Gitly, but it doesn't. And we can check why that is if we look at Redis, and it's because there's a branch name cache here, which is used. So we've got this S-members Redis operation on this, and we can open up the backtrace, and we can see that this is coming from, where is it? Issues controller related branches, branches with IID of. So we're checking if branches exist with this issue's internal ID, but we're doing that by storing that in Redis rather than hitting Gitly on every single issue load. So that's a little bit of an optimization there, and the time it takes in Redis is 14 milliseconds, which it's actually possible that Gitly could beat, but the request volume to Gitly could be excessive. The other thing you can do with the plus button is going to require me to reload the page. So you can also put a request ID in there. So every request you make to GitLab gets a unique request ID. That's used for a bunch of things. And for instance, my avatar actually hits GitLab because it's an upload. So I've uploaded my avatar, it's not a gravatar. And that means that we do need to do some checks to actually find that file and serve it to you. You can see here I've disabled the HTTP cache while DevTools is open. That's just in case it was cached by my browser and then I wouldn't get any results. So I've got the request ID from the X request ID header. I can paste that in here. That will show up in the dropdown. Again, this time it won't be very friendly because it will just use the request ID. We don't know what the URL was. We just know what the request ID was. And here we can see that when I load my avatar, it runs 6 queries. They're all very, very fast queries in the context that we're talking about here. None of them are bad. These do seem unnecessary, especially these two, because they are literally the same query. This one seems like it might be 100% necessary because it's checking that the file for my avatar actually exists. But these two, one of these is in finding the model for the upload, and the other one is in finding the model for the upload. So it's possible that we can memorize that, save it in memory in Ruby, and avoid hitting the database again. Again, with a query time of 0.8 milliseconds. It's not the highest priority in the world, but it is something that we could easily fix with very little change on the Ruby side and see a small improvement. And of course, user avatars are used very frequently. So even if it's saving 1 query per avatar load, that will add up to quite a lot of queries over the course of an hour's traffic on GitLab.com. So those are the 2 modes for the plus button. The only other thing to mention is that in development mode, which I have over here, this has an extra feature. So first of all, you can see the performance bar's background color is different. That's just to indicate that it's in development mode. The performance bar is also enabled by default in development mode, whereas in production, you have to hit P, then B to enable it. In development, it defaults to on. You can always toggle the state by hitting P, then B. The extra thing that exists in development, but not yet on GitLab.com, is this trace button, which enables us to use Jaeger distributed tracing to use the request ID that I mentioned earlier to trace a request through. So for instance, for this merge request, we can see that it calls find commit a couple of times. We can also see that in Jaeger. Oops, that's because it's expired, I'm sure, so I'll need to refresh the page. Okay, right, there we go. So we can see that, this request made 2 Gitly calls, which we knew from the performance bar. We can also see that there's 2 elements from GitLab Workhorse and 372 events from web, or spans, as Jaeger calls them. So some of these correspond to SQL queries. Some of them type in here find commit. We can find the first find commit call to Gitly and some information about that. So we're still working on the integration of Jaeger on GitLab.com. And once we do that, hopefully these will be slightly more integrated tools. For now, we can treat them as doing largely the same thing. And Jaeger is a thing to experiment with in development because it gives you much more information. Obviously, the performance bar is limited to a UI that's 1 line high plus a modal. Whereas Jaeger is its own application with its own rich, full-featured UI where you can see exactly within the timeline of a request when an action happened. But like I said earlier, Jaeger is not enabled on GitLab.com currently, so that is a a thing that means that it's not necessarily the top priority for anybody looking to learn about this, but more a thing to keep in mind for future. You can also skim through the different find commit calls with this, whereas with the performance bar, you'd just be using your browser's find in page feature. So yeah, that's kind of it for the performance bar. We have, Postgres, Italy, Redis information captured with backtraces. We have the host that you're on. We capture AJAX requests made by the same page. We allow you to add a request manually in 2 different ways. And hopefully it's a useful tool to have enabled all the time while you're browsing GitLab.com, just to keep an eye out for either for these warning icons or just for anything that seems a little bit odd, like with the avatar request, where we might be like, well, do we really need 6 SQL queries to determine whether we can display a user's avatar or not? It might seem excessive. So thanks very much for watching this.